In this video, we will look at greatest common factors. But before we do that, we have to understand what factoring is. So we know when we start with an expression that looks like this, where we have brackets, if we apply distributive property, we are expanding our expression to get rid of the brackets, and then potentially we can collect like terms. Factoring is the exact opposite of that. So we take our expanded form and we factor to reintroduce the brackets. There are many methods for factoring, but the first one is called a greatest common factor, and it is the first question you should always ask yourself before you apply any other method that we will be learning later on. So if you look at this example here, to get these brackets, so the bracket and the monomial in front, you might notice, well, a common factor between 5 and 15 is 5. If I look at x squared and x, they both have an x in common. And then to get the leftover brackets, you're kind of asking yourself, what should I multiply 5x by to get 5x squared? And that's x. What should I multiply 5x by to get negative 15x? That's negative 3. So if I were to apply that distributive property, I would end up with this expression. So the first step is always to determine the greatest common factor. You're going to check your coefficients, and then you're going to check your variable. So let's look at our first example here. Between 8, 4, and 12, 4 is a greatest common factor because all three coefficients can be divided by 4. Then, when we look at the variables, we have x to the 4, x to the 3, and x. They all have an x in common, but they have different exponents. We're always going to take the smallest exponent because that is the most that can be taken out of every single term. So x is the most I can take out. I can't take out an x cubed because then 12x would be stuck. It doesn't have enough x's to remove. Now, once you established your greatest common factor, we are going to write an equal sign. We'll put our greatest common factor out in front, and then we're going to open up a bracket. At this point, we're looking for that leftover bracket so that when I multiply the 4x in, I'll end up with this trinomial. Now, you can look at this in different ways. You can just ask yourself, what should I multiply 4x by to get 8x to the 4? But because we know multiplication and division are opposite operations, instead of doing a little bit of guess and check here, you can really just divide each term by that greatest common factor. So 8x to the 4 divided by 4x. And if I do that, 8 divided by 4 is 2. X to the 4 divided by x is x cubed. And then a double check. 4x times 2x cubed is 8x to the 4, so I'm happy. Then I'll do it to the next one. 4x cubed divided by 4x. Well, negative 4 divided by 4 is negative 1. X cubed divided by x is x squared. And finally, 12x divided by 4x is just positive 3. And there it is. And you, like I said, you can do a check here. We already checked the first one, but if I do 4x times negative x squared, I do get negative 4x cubed. 4x times 3 is 12x, so we know we did this correctly. So identify that greatest common factor by looking at the coefficients first, and then the variable with the smallest exponent, and then we write our common factor out in front, and to get the brackets, you can do a little guess and check based on your knowledge of distributive property, or you can just use a bit of division. So let's try examples. All right, we're going to factor the following polynomials. So in 12x and negative 3, if I look at 12 and 3, they have a 3 in common because both numbers can be divided by 3. And then in terms of the variables, the first term has an x, but the second does not, so that's all I can do. So I will write my GCF, I will write a bracket, and then I will divide each term by 3 to get my leftover bracket portion. 12x divided by 3 is 4x, and negative 3 divided by 3 is negative 1. Make sure you write the negative 1 because anything divided by itself is 1. Don't just close your bracket after 4x. If you start with a binomial, you have to have a binomial in the brackets as well. All right, and that would be it. So the next one. If we look at our next one, B, I'm going to look at 20, 10, and 5. They can all be divided by 5. Nothing more, or else 5 would end up with a decimal, which we can't have. Then they all have an a in common. We have an a to the 4, a to the 3, and an a squared. A squared is the smallest exponent, so that is the most I can take out. So I'll write my GCF in front, I'll open up a bracket, and now to get the leftovers, you can just ask yourself, what should you multiply 5a squared to get each term? Or just divide everything by 5a squared. So 20 divided by 5 is 4. A to the 4 divided by a squared is a squared. Remember, when you're dividing variables with the same base, you just subtract the exponents. Negative 10 divided by 5 is negative 2. A cubed divided by a squared is a to the 1, or just a. And then 5x a squared divided by 5a squared, that's just 1, because anything divided by itself is 1. And that would be it for that one as well. Now, it is very important that when you're identifying your coefficient and your variable, that you are grabbing the greatest common factor and not just a common factor. So you would always have to kind of check your bracket at the end to make sure there's nothing more that you can divide out. All right. For C, how about you pause the video and try this one out on your own and then come back to check your work. So for your greatest common factor, it should have just been a 3. The variables are not common to everything, so that's all we can take out. Make sure you have an equal sign, the 3, then the bracket. 18 divided by 3 is 6, and then m squared. Negative 3 divided by 3 is negative 1, so negative m. And 9 divided by 3 is 3. And there you have it. All right, for the next few, I have added more variables for us. So we just have to take a closer look at what that common factor might be in terms of the variables. So for D, if I look at the coefficients, 6, 12, and 24, this is where I want you to be careful. You might look at this and be like, oh, 2 is a common factor. It is, but it's not the greatest because you can divide each of those coefficients by more than just 2. And in fact, our common factor is 6, the greatest. And then I look at my variables individually. So I see I have an x, I have x squared, x, and the last term doesn't have an x. So I can't factor that out. But they all have a y. So my greatest common factor is 6y. And we can just divide each term by 6y. So I open up my bracket. 6 divided by 6 is 1. The x squared stays, and the y's cancel out. Then 12 divided by 6 is 2. The x stays, the y's cancel out. Negative 24 divided by 6 is negative 4, and the y's cancel out. And there you have it. For E, more variables, but same idea. So for my greatest common factor, I'll look at the coefficients first. So 27, 3, and 9. 3 is the most that you can divide out. And then I'm going to look at my variables carefully. I have p to the 4, p to the 3, and p. P is the lowest. Then I'll look at my q's. Q squared, q to the 5, q to the 3. Q squared is the lowest. And finally, for the r's, we have r cubed, r, and r squared. R is the least that we can take out. So we will write out our common factor, open up a bracket, and then we'll divide each of these by the common factor. All right, so 27 divided by 3 is 9. P to the 4 divided by p is p cubed. Q squared divided by q squared is gone. R cubed divided by r is r squared. Minus negative 3 divided by 3 is negative 1. P cubed divided by p is p squared. q to the 5 divided by q to the 2 is q cubed. R divided by r, nothing. They cancel out. Make sure you don't put an r because technically the exponents are both 1. 1 minus 1 is 0. And anything to the power of 0 is 1. So it's gone. Plus 9 divided by 3 is 3. The p's cancel out. Q cubed divided by q squared is just q. R squared divided by r is r. So make sure for these ones you take them slowly so that you don't make a silly mistake with the division. All right, why don't you try F on your own and then come back to check your work. All right, so your greatest common factor should be 5a cubed b. Anything more for the exponents is too much. So I'm going to divide all of these by 5a cubed b. I'm just going to show it as one division, but I'm going to make sure I always come back to that greatest common factor so that I don't make a mistake. So 25 divided by 5 is 5. A6 divided by a3, a3. B cubed divided by b is b squared. 15 divided by 5 is 3. A to the 4 divided by a to the 3 is a. And b to the 5 divided by b, or b to the 1, is b to the 4. Minus 10 divided by 5 is 2. The a cubes cancel out, the b's cancel out, so there it is. Okay, so check to see if you got that correct. If you did, fantastic. If you made a mistake somewhere, was it your greatest common factor or was it the bracket portion? Maybe you misdivided something. Okay. Let's try G again. Pause the video, try it on your own. If you made mistakes in F, try to think of those and not make those going forward. All right, so your greatest common factor here should be 6x cubed y. So I'm taking the lowest exponent for each of my variables and the most I can divide out from all three coefficients. So over here, if you said 2 or 3, although they are common factors, they're not the greatest. And if you were to do that, you have not fully factored your expression. So I'm going to divide everything by my common factor. And now make sure you write the common factor at the beginning, open up a bracket, and now we do the division. 24 divided by 6 is 4. X to the 6 divided by x to the 3 is x cubed, and the y's cancel out. Negative 6 divided by 6 is negative 1. X to the 4 divided by x to the 3 is x. Y cubed divided by y is y squared. 12 divided by 6 is 2 for the coefficients. The x cubes cancel out, and y squared divided by y is y. Okay. And again, if you made mistakes here, take note and try H as a final check before we add one tiny twist for the last few. So pause the video, try it out, then come back to check your work. So your greatest common factor here between 8, 16, and 12 is 4. Okay, although 8 is a common factor between 8 and 16, you cannot divide 12 by 8, so be careful there. They all have an m in common, and the lowest exponent is 1, so just m. They do not all have an n in common, so we cannot put that as our common factor. When we do the division, 8 divided by 4 is 2, m cubed divided by m is m squared. Negative 16 divided by 4 is negative 4. M squared divided by m is m, and then the n, don't forget about it. It wasn't divided by anything, so it's still there. 12 divided by 4 is 3. The m's cancel out, so we just write the n squared at the end. So once again, we looked at the coefficients to get the greatest common factor, so knowing your multiplication here is important. For the variables, we took common variables and looked at the lowest exponent and used that. All right, the next ones, you will notice that you have some brackets in your expression. When you have brackets, specifically in this scenario, if the brackets are identical, your common factor can be a bracket. That's okay. We need to look at these terms as units or a single term, even though there's a bracket there. They're attached by multiplication so we can see them as one. Each of those units has that common bracket. So my greatest common factor is m minus 2n. And we've been showing our GCF as division. So let's show it here to figure out what we're left with. So normally our common factor is a monomial, but here it's a binomial. So I'll write it in brackets. That's my GCF. Then I open up my bracket, and when I do my division, the first unit divided by my bracket, well, the brackets just cancel out, and you're left with 5x. And the second unit, again, the brackets are identical, they cancel out, and you're just left with the plus 3. So the bracket was the common factor, so I wrote it at the beginning. Your second bracket came from the monomial in front of each bracket. Let's try it again. In the next example, a plus 2 is common, so that will be my common bracket. And it is very important that the brackets are identical. If they were not identical, you wouldn't be able to factor this. So I will show my GCF as division. I will write my bracket, and my leftover bracket will be, well, these brackets cancel out, so I'm left with 6a. These brackets cancel out, so I'm left with negative 5. And there we are. Okay, for K, one thing I'm going to do, and then I'll have you try it on your own. There is a positive 1 in front of that bracket. That might just be helpful. So why don't you pause the video and try this out on your own, and then we'll take it up. Okay, so our greatest common factor is the q minus r. So I'm going to divide each term by the common bracket, which you don't have to show this division, but if it helps you, show it. The brackets cancel out, you're left with 3p. The brackets cancel out, you're left with plus 1. And there you have it. All right, one final twist here. You will notice that in the next 3 examples, we have 4 terms. And if we look at each of them, there's actually no common factor. So if we look at this, 3, 6, 5, 10, there's nothing common in each. X cubed, x squared, x constant. We can't factor anything out. You're kind of stuck here. So when you have 4 terms, we do something called grouping. And this grouping is supposed to help you pair up 2 terms that might have something in common. So if I pair up the first 2 and the second 2, I might have a common factor in each pair. So if I look at 3x cubed and negative 6x squared, they both have a 3 in common, and they have an x squared in common. So I'll put my common factor, and I'll just factor it out from the first 2 terms. 3x cubed divided by 3x squared is x. Negative 6x squared divided by 3x squared is negative 2. Now let's look at our second pair. Between positive 5x and negative 10, we can factor out a positive 5. So I'm just going to continue. I'm going to show it's positive, and then 5x divided by 5 is x. Negative 10 divided by 5 is negative 2. Once you did that grouping, you should notice, hey, my brackets are the exact same, which puts us in one of those previous examples. My greatest common factor is going to be that common bracket of x minus 2. And we know that if we divide out the common factor, your second bracket will be 3x squared from the first pair. And then when the brackets cancel out from the second pair, you're left with positive 5. So there it is. So a little bit of pairing up, and then you're back to identical brackets. If the brackets were not identical, it would just mean that this is not factorable. Or it could mean that you made a little mistake somewhere that you have to go back and check. Okay, let's go to the next one. I look at them. There are no common variables for all 4 terms. 10, 15, 12, 18, all 4 coefficients do not have something in common. So I will pair them up. Between 10 and 15, I have 5. They both have an A, they don't both have a B. So 10AB divided by 5A is 2B. 15A divided by 5A is 3. For my next one, we're looking at negative 12B and negative 18. When your first term is negative, you have to factor out a negative. It's a must. So right away, I'm going to put negative, and then 12 and 18, you can divide them both by 6, and they don't have a common variable. So I'm going to write minus 6, and now I'm going to be super careful with my signs. Negative 12 divided by negative 6 is positive 2, and then the B. Negative 18 divided by negative 6 is positive 3, and because we were super careful, the brackets match. And once you get the hang of having the common bracket, 1, there's the common bracket, and your other bracket comes from the monomials in front. You can show it with the division like we did in previous steps, but after you do enough practice, you should be able to get here. And you will see that this grouping method is going to be part of decomposition, and that's why we're practicing it right now. All right, the next one. You might be in the habit of now saying that if there are 4 terms, group right away. But actually, if we look at this, there is actually a common factor to deal with at first. And the common factor is 2. So when I divide by 2, I'll have 3x cubed plus x squared minus 6x minus 2. And then we're going to group next. So sometimes you're going to have to do 2 methods to factor. And you know, when you're doing it, you might not know if it is grouping, but you still have to try. So for my first pair, there is an x squared in common. So first of all, don't forget to write that common factor, the 2. Don't forget about it, or you're changing your expression. All right, now we write that common factor of x squared. 3x cubed divided by x squared is 3x. X squared divided by x squared is not 0, it is 1, so make sure we write that plus 1. And then when we look at our next pairing, there's a negative there, so my GCF will be negative right away. And then between 6 and 2, 2 is the common factor. So I'll put my negative 2 out, and then negative 6x divided by negative 2 is positive 3x, and negative 2 divided by negative 2 is positive 1. Brackets are matching, very good sign. So I wrote my original common factor of 2, then I'm going to write my common bracket of 3x plus 1, and when those cancel out, we're left with x squared, subtract 2 for the other bracket. And there we have it. So we have the typical common factoring that we did at the beginning. However many terms you have, look at the coefficient, look at the variables. Sometimes you might see common brackets, and sometimes there might not be any common factor for 4 terms, but grouping will help save you. And that's it for the GCF.